Hi everyone, this is Arik from Futurely, and I'm here to cover another introductory session of ours. And today we'll be talking about Grasshopper. As you may know, Grasshopper is a computational design program that comes with Rhino. Don't let that term scare you. Just know that it's a very cool plugin that comes with Rhino. So as you install Rhino, you will have it, and we will know the uses of it. Although it's very, very wide, there's so many usages to it, but we'll get into the vibe of understanding when or why you would be using Grasshopper in the first place, right? And as a means, what this video will do for you is give you a good crash course, so to say, into Grasshopper, so you can learn to read Grasshopper files or modify Grasshopper files, or even learn more advanced techniques with Grasshopper as you go forward. So without further ado, if you have Rhino turned on, all you have to do is come here to the command bar and type Grasshopper. By the way, if you are new to Rhino, you might want to watch our Rhino introductory course before you watch this one. All right, let's go. So turn on Grasshopper. And then usually if you have just one screen, you might want to get your Grasshopper window all the way to the right, and then your Rhino window all the way to the left. So from there, usually I like to turn this one off so that it doesn't bother us. And then let me tell you why you would need Grasshopper next to Rhino. So for example, let's say we want to create an interpolate curve here. And let me shade this in. And then another interpolate curve, let's say. So, and then let's lump them together. Let me flip this one. And from there, let's say I want to change this curve. You'll see that the curve is separate. And if I want to change the surface, I have to change it separately. So I lost the link between this curve and this surface already, right? And let's say we want to do something more complex, right? More tedious, more labor intensive. So let's say I want to divide this curve into 10 segments, and this one as well. And then I want to create a line between each of these points. So that's a lot of tedious task, right? I'm doing the same thing over and over, which means I'm not really using my brain over here. All I'm doing is just repeating the same thing over and over. And the worst thing about this is that what if I change my mind and I'd be like, okay, I just want to see how it looks when it's 20, right? So when it's 20 segments. So that will be just repeating the same task over and over again. And that means that that's a lot of time wasted. So here's where Grasshopper comes, right? Let's say we want to do the exact same thing, but we want to do it in Grasshopper. What we would do is reference these curves into Grasshopper, which means they won't be only Rhino curves from there on, but they will be also Grasshopper curves. To do that, all you have to do is come to the primitives here, and then primitive in this part, and then look for curve here, or actually geometry, and then look for curve here, and then from there, you can just drop this in. And what this does is that it creates a component. This is what this is called. It's called a component. And now it's telling us that it's failed to collect data. So it means that it's empty, or at least there's nothing going on here. So when it's orange like this, there's some kind of thing missing for it to work. So this means that it's just an empty curve, nothing's going on so far. But to get this to read the curve from Rhino, all you have to do is right click on this and then go to set one curve. And then from there, just click on this curve here. So what that does is that now it turns white or light gray, and then that means that it's already reading it. And if I click on this, you'll see that it turns green to highlight which curve that is in Grasshopper. So now I can duplicate this. I can drag this now, and before I let go, I'm gonna press Alt, and then I'm gonna let go, which creates a second geometry node for me. So from there, I'm gonna set one curve, and I'm gonna select this one, the next one. So right now we have both of these curves in Grasshopper. So we're gonna be doing the same thing, right? Let's say we were dividing it in Rhino. What we will be doing is divide it in Grasshopper. So I'm gonna double click here. So if I don't know where that is, and there's so many things here, you may not have all of these here, and that's because I have additional plugins installed into Grasshopper, which we'll get to in a second. I'll show you how to do that. So, but before that, let's cover this example. So if I double click somewhere, it's gonna give me the search prompt, right? So if I come here and I do divide curve, I'm just gonna type divide to see if I have something that gives me a divide curve thing, right? So from there, I can see that divide curve might be what I wanted. It's not probably the arc divide or divide distance or something like that, right? So for now, I'm gonna come to divide curve. So usually this is what you'll be doing. So you'll double click somewhere and look for things, right? So divide curve, and you'll see that this component is a little bit more complex, so to say, compared to this one right here. And from there, you can see that it has some letters on the left and some letters on the right. And this is what most component will have. This means that the inputs on the left are things that come from the left, and then they come out as outputs from the right. So it takes 3 inputs and it gives us 3 outputs, this component right here. And if you hover your mouse on one of the inputs or the outputs, as at the letters at least, you'll see what it wants from us. And this one wants a curve, right? You can see that it has the same icon as this one does. And usually if you see this hexagonal icons, it means that it's just prompting some kind of a data type. And there's so many data types here, but most of them are basically in geometry and primitive right here. And you'll see that you have some data types that are numbers, some integers, some text, and then you have curves. Brep is basically solids or surfaces that come from Grasshopper or anywhere really. So this is what they are called here. They're called breps. For some reason, they're not called surfaces or solids. Then you may see meshes, sub-Ds. So there's a lot of stuff here. Points, vectors, right? So for now, what this takes is a curve. So if I take this curve from here as an output and put it into the input of this component here, I'll see that it already did something. It divided this curve. And if I come to n, I'll see that it's an integer. When you see the 7 in a hexagon, it's an integer. And if you don't know the number, if you don't know the difference between numbers and integers, is that numbers are floating numbers and they have decimals, right? And they can be integers, but the integers are basically numbers that are whole. Basically, you have this, they're either 1, 2, -3, right? They're not like 3.5 or something like that. So this thing wants an integer from us, but this is not what we want. If we take an integer here, it's not gonna do a lot for us. So what we will do instead is give it a slider. So sliders are a really cool feature of Grasshopper. And the way they work is if you double click somewhere, and then let's say I type a number here, right? So let's say I'm typing 5. It already gives me a number slider here. And if I hit enter, it's going to give me this slider here. And if I take the output of this to the input of the count over here, you can see that now it's giving us 5 segments and 6 points. So I can come here and change it right away, and you'll see what happens here is that I don't have to recreate this all the time. As I change the slider, this changes with it. So this is really cool. What if I want to change the range of this slider? All you have to do is double click on the count over here, or at least this part where you have this darker gray area. And then you'll see that you have the minimum and maximum that you can change. I'm going to change the maximum to 50 here. And the numeric value is what it's going to be on as a value. And then the range is basically the difference between the maximum and the minimum. So if I hit OK, you'll see now that this changed, and now it's going from 0 to 50. Another way you can do this is, I'm going to delete this for a second. Another way you can do this is if you double click, instead of just typing one number, you can type something like this, 0 smaller than 50. And then if you hit enter, that's going to give you a slider that goes from 0 to 50. And that's a quicker way of creating that. And you can also do, let's say 0 to, or let's do 0 to 15 to 60. And then with that, you'll see that it's going to give you 0 to 60, but the initial number will be 15, basically. And another thing here is that you can do let's say instead of 5, we type 12. It's going to give you a range between 0 and 100, right? So the closest number that is a multiplication of 10, let's say, that will take to the largest. So as you can see, if I double click here and let's say type 500, it's going to give me 0 to 1000, right? And if I do 1000, it's going to give me 0 to 1000. And then if I do 1001 even, it's going to give me 0 to 10,000, and then basically start going like that. Anyways, the multiplication of a 10 wasn't a great definition of what happened right here, but I think you get the idea better as I showed you multiple examples of what's happening. So right now, we're going to go with this. And I have this other curve, and I'm going to create another one from this divide. And then instead of using this curve here, I'm going to use this curve. And you can see that the other curve got disconnected. And now we have this slider controlling both of the divisions. And this is cool because you can use one input to control 2 outputs. And this is really cool. Unless you want to control them separately, this is what happens, right? Let's keep this like this for now, and then we'll get to the different divisions a little later. So if I come here, you'll see that these are the points that it's giving us, and other is it's giving us a tangent here. So you can see the points are an X icon in the outputs, and then here T are the tangents, and if you see this arrow icon in the hexagon, it means it's a vector data type, right? So tangents would be basically, let's say if it's this point, it would be the tangent vector at this specific point. But we don't need that for now. And then there are the parameters, which we'll get into later, or we won't because they might be too advanced for this session. For now, let's focus on these points here because that's why we created it in the first place. And you're always going to hover on top of these inputs and outputs to see what they're giving you. And we wanted points. So as we hovered on 3 of these, we understood that what we wanted was the first one in the first place. And now we want to create a line, actually multiple lines between these points, right? So I'm going to double click and I'm going to type line here to see what I want. And you'll see we have 2 lines here. One of them is a hexagon, and there's a line in there, and then the other is just a line. So if you see this hexagon, it means it's probably something you would want to reference either from Rhino or from another set of geometry in Grasshopper. This time we're not referencing anything, right? So we're gonna go with this. This is what will create a line for us. And the description says create a line between 2 points. This is what we want. So we're just going to click on this and we're gonna go from there. Awesome. So it takes A and B. And if we hover on it, it shows that it wants points from us. And then that's the start point and B is the end point. So this would be our start points and these would be our end points. And you can see it gave us something like this. And although it looks cool, if you wanted the basically each of the points that are closer to one another to connect with each other, you would want to flip one of these curves. And you can either do that in Rhino. I'm going to select this curve and flip it, and that will fix this for us. Or if you don't want to do that in there, you can do that also in Grasshopper. If you just type flip curve, and take that, and then it, of course, wants a curve from you, and this is the flipped curve, and then that goes into the division, and then the rest is just what it was from there. So this is also a very cool thing you do with Grasshopper, right? You basically also change things along the road, even if the whole command line is complete. And this is nice. I'm going to actually flip this in Rhino. And the coolest part is that if I change this number now, you can see the whole code, let's say the whole script. And this is not a script, this is a code. Script would have text in there. So this whole Grasshopper definition will run again, right? So I'm going to do this, and you can see I don't have to redo any of this again. Even if I go ahead and change these curves, the whole thing will update. And that's the basically best thing that Grasshopper does for us. If not the best thing, one of the main things it does for us, right? It remembers the history. And as you change, even in the very beginning of the definition, the whole change will basically take place and affect the whole output. And this is really cool. So we can change the curves, we can change the divisions, etc. So yes, what if we have different types of divisions, right? And to do that, I'm going to copy this slider right here, and I'm gonna input it to the other one. And what I just did was hold Alt, actually drag this, and then hold Alt, and then place it into the other. And what that will do is disconnect the other input and input this one. So this is cool, although you may actually you didn't need to do that here, but in some cases you will need to do that. So for example, if you want to add 2 curves in one place, you might want to do Shift and do this, and then that will add instead of disconnecting the other one, it will add on top of it. So that's Shift, and then Alt will do the opposite. Will basically disconnect all others and connect only the one that you wanted to connect. So although it wasn't very useful at this time, but you will definitely need it at some point, so better keep that in mind. All right, awesome. So right now we have different divisions, right? And let's see what happens. Let's put 10 here and then 15 here. And as you may see, what's happening is it's 15 here and then 10 on this one. So this last one here is connecting to the rest of the points, right? So the 10th point is, let's say it's here. And then after that, 11th, 12th, 13th, 14th, and 15th are basically being connected with the 10th here. Or let's say 11th and the 16th, because it's 15 divisions. So you have +1 on each side. So anyways, I think you get the point of what's happening here. And the thing is, I'll explain why this is happening. And for that, what we will need to do is watch this a little closer. So for this, you will need a panel, which is this guy right here. And the shortcut for that in the search keyword would be, instead of typing panel, what you can do is /, and that will give you a panel again. So here we're going to watch these two sets of points. And the way we do that is, once you input anything into your panel, it's going to show you what this output is giving you, right? And the way you can read this is that we have 16 points. I'll tell you how I read that. So it's starting from 0 in computational design, and in programming you'll start with 0 most of the time. So in Grasshopper you'll always start counting from 0. So here you can see that we have 16 points because we're starting to count from 0 and the last number is 15. And the way we know these are points is because it has 3 coordinates, is basically the x, y, and z coordinates of each point. And the other one is looking similar, but instead of basically 16, we have 11 points here. And why is this important? It's super, super important for you to be able to read this way and keep basically adding panels wherever you need to get more information from. So I'll use these panels to explain what just happened right here. So let's say we have 5 here and then 5 here. So both of them are equal to one another. We have 6 points on each curve. And in this case, what happens with the line component is it connects, or it matches, let's say, the point at index 0 to the point at index 0 from here. And then 1 gets matched with 1. And then basically keeps going like this until 2 gets matched with 2, 3 gets matched with 3, and then finally the point at index number 5 will be matched with the point at index number 5 from the second list. So this is what happens, right? And this is very, very straightforward. But as soon as we change this, let's say to 8, and we have a larger list here. So 0 gets matched with 0, 4 gets matched with 4, 5 gets matched with 5. But then what happens is basically, I think you guessed it already, 5 gets matched with 6, and then 7, and then 8. So this is what happens in lists in Grasshopper by default, right? So this is the default of what happens. And this is called longest list, right? There are multiple ways these two could have been matched together. One of them is basically, let's say 5 gets matched with 5 in the end, and then it stops, right? So these two get matched with one another, and then it stops. So these get ignored, let's say. So that would be shortest list that can come out of the matching of these two lists. And by default, in Grasshopper, you will get always longest list. So in case you wanted to have shortest list, what you would do is double click here and then type shortest list and get this guy right here. And then before you input this into the lines, you would input these into the shortest list and then into the line right here. And then in that case, you can see what happens is, let's watch the list here. You can see that it ignores the last three compared to the original one. And then you get overall 6 lines instead of 9. So here you'll see that the last 3 are being ignored here. So if I raise the number here and even this higher, the extra points will be ignored. This is very, very crucial to understand, although simple. It has its many applications. So really cool. The other way you can match 2 lists is all with all. Let's say this is 5 and then this is 7. So we have, let me delete this shortest list right here. Then we can have these 2. So another way we can match it is basically not 0 to 0, but let's say 0 to 0 at first, and then 0 to 1, 0 to 2, 0 to 3, 0 to 4, and all the way to 7. And then start with 1, and then go to 0, 1, 2, 3, 4, 5, 6. So this means like it's cross-referencing. It's crossing all the possible matches that can happen between these 2 lists. And the way that can happen is basically cross-reference. And this is another way of matching 2 lists. And if I put these 2 points here, before I input it into the line here, you can see what happens is we get all the possible combinations. So this is cool. As we change it, you'll see that what happens is it looks really beautiful. So you can see we get, instead of getting 0 to 0, 1 to 1, what we're getting here is basically all the possible combinations. And this is what's called cross-referencing. So far, we've learned 3 ways we can match 2 lists. Longest list is by default. So most of the time, you will not need to add a longest list component into your definition. So most of the time, you might need a shortest list or cross-reference right here. Also, let me give you another tip here. If you go to display, you can, instead of throw icons, you can use text. So if you turn on throw icons, what you will have is basically the text showing up. And you can also say draw full names, and it will give you full names. Usually what I like doing is short names and then without drawing icons. But right now, there's a very cool trend that we do. It's a cool plugin that even if you're drawing icons here, that plugin is called Bifocals. And if you put it into your scene, what you'll get is the text on top of your components, even though you're using icons here. I'll show you how to install this in a second. But until then, let's just keep going. So this is icons and text right now for your reference. But you don't need to do this right away. We'll get into it in a second, I promise. Okay, so let's talk about some other thing here. And that is list structure. So let's say we have this list here. What we call this list is just a list. It's a flat list. And the other type of list you might see is grafted lists. And for that, I'm going to have a graph tree component here. And as soon as I put this here, and I'm going to create another panel to watch this, you'll see that this is not just a flat list anymore. It's a list of lists, right? So each of these, where the dark gray banner starts, is a separate list. So this is a lot of lists, and each list has just one item inside, right? So this is one list that has 23 items inside. These are, and this is where you read them, the number of the list. These are 15 lists because it's starting from 0. And each of those 15 lists has just one item inside, although we can have more items. Why is this even important, right? So you'll see, I think this is the most important thing you will ever learn in Grasshopper, because no matter what you do, you will have to deal with this. But for now, just keep in mind that there are such things. All right. So what happens if we want to match these two lists together? So let's delete this cross-reference. And so if we match two flat lists together, what we get is what we were talking about from before. Basically, we get 0 to 0, 1 to 1, 2 to 3. So each of the two indexes get matched together, right? With longest list by default. If one of them is grafted, actually, if let's say both of them are grafted, right? And then you have something like this. And then we input these two into the lines here to create a line. You'll see the outcome is very, very, very similar, but the outcome in terms of list is a little bit different. It's not a flat list anymore. It's a list of lists. So again, the matching happens. Nothing special happens with the matching, right? 0 goes with 0, and then 0 goes with 0 of the next list, and then 0 goes with 0 of the next list. So you don't see any difference as long as the structure of the two lists are similar. And so if the structure is similar, you'll get no surprises in the end. But if the structure is not similar, let's say one of them is grafted and the other is not grafted, and you might see that in the wiring too. You don't really need a panel to see this. You'll see that grafted lists, or actually lists of lists, are dashed like this. And then if it's a flat list, it's something like this. And then in case of just one line, it's just a single element. And then this is multiple elements. And then here you have list of lists, right? You have multiple lists here. So what we get in the end is something like this. What if one of them is flattened and the other is not flattened, right? So we'll use the flat version of this one with the grafted version of this one. And what you'll see is similar to what we had before. We'll get a cross-reference right away. So what happens in this case, let me dial down the numbers here a little bit. Let's do 5 with 7, or even less. Let's do 3 with 5. So this list is just 4 lists of one element in each. And then we have another one, which is a flat list of 6 items. So in this case, what we receive is basically 0 from list 0 here goes, because we're doing longest list, right? So goes with this one. And then because it's longest list, it keeps going with 1. Let me draw this better. So this goes with 0, 1, 2, 3, 4, and 5. And then the next one keeps going. And we get 0 with 0, 1, 2, 3, and 4, and 5. So in this case, each list gets matched. Let's say this whole list gets matched with this whole list here. And then the next list gets matched with the whole list here because it's still going on longest list. And in this case, you will get a very, very similar result, actually identical result to cross-reference. So this is cool. Let's apply this on a bigger example next. But before we do that, I'm going to show you how to install some plugins. All right, so here I have some websites open, and most of the plugins that you will download will be from foodforrhino.com. You want to create a user for you and then go from there. And let's say we want to download this Bifocals that I just showed you. And all you have to do is click on it, and then you look for the latest version. And usually it's the one on the bottom, and then you download it, and this is cool. So we have this one right here. And then from there, what you want to do is open this thing right here, and then let me put this here. And then from there, you want to unblock it. And then, so if you right click on this and go to properties and then unblock it, that's something you really need to do. And then from there, what you can do, this is the fastest way possible. You can just drag this, come to your Rhino and drop it into Grasshopper. And now I have this plugin already, so I'm not, it's asking me to replace, but in case you don't have that plugin, it's just gonna put it right here, and then you will already see it, and then you can just drag and drop it here. So there's also some other plugins you can download here, like Anemone is a very cool one that you can download from here. Pufferfish is a very cool one that you can download from here. So just try to download them and install them and get used to this whole thing. But the other thing is that you will see that sometimes you will need a website and a proper installation file to install a plugin. And for example, LunchBox is like that. So you want to go into Proving Grounds website, and then from there, you want to go into LunchBox and then download for free. Then from there, you might want to actually, yeah, it's free, but you still have to purchase it, check out, fill in your info and things like that, and then use your free download. I've already done this, so I don't have to do it again. But what this gives you is a LunchBox installation file instead of a GHA file. So usually plugins will be GHA, but in this case, it's an installation file, and you want to turn off Rhino and then right click on this and open it. So the other type of thing you'll see will be a GH user file. Sometimes you'll see GH users as plugins, but other times somebody might give you a GH user file. In that case, the installation is very, very similar, and you might want to also unblock it. And then for this one, actually, remap2 file is something created by me personally, so actually we'll be using it in this session. So you want to install this as well. So this will either be in the description or in the download section. Just try to look for it, and if you don't find it, just let me know. All right, so this is installed exactly the same way. It's just dragged and dropped into Grasshopper, right? And another way you can install things is, for example, this is a very special one. It's the Weaverbird plugin, and it's used a lot, and it's a very cool topological mesh modeler that you can find if you Google Weaverbird Grasshopper. And for this, you have to download Weaverbird for Rhino 6+7, and all you have to do is just open this Grasshopper definition here in Grasshopper, and that's it. It gets installed. And then after that, you have to come here and go back to your definition, or just go out of there. And that's it, right? So these are a few ways you can install plugins. You might not want to overwhelm yourself with all the plugins right now. Let's go ahead and do the next example, which will be a little bit more exciting than this. All right, let's delete all of that and open a new Grasshopper document here. And let's do a surface, right? Let's do a plane starting at 0. Let me type a specific number so we get a sense of the scale, maybe 10,000, so it's like 10 meters. This is in millimeters, my file. So I'm going to do 10,000 by 10,000. So we can have something like this. Then I'm going to rebuild it. Let's say the degree is 3 by 3, 10 or 5 by 5 here, and then OK. If you didn't understand what I just did, that means you're probably new to Rhino. You might want to watch our Rhino introductory session as mentioned in the beginning of this video. So let's go here and then F10. And let me edit this just a little bit. Maybe let's drag this down. Let's maybe take these two and drag them down as well. I'm going to take all of these guys. I'm going to click on this here and 0 so that it can average and be on the same level. Or let me just drag this down a little bit more. Okay, cool. So we have something like this. It's like a surface, a shell one. And what we'll be doing is we'll be dividing this into panels first. And for that, I'm going to be using LunchBox. So if you haven't already, please install it because for this one, you are going to need it. And if I come to panels here, I can see I can divide this surface into multiple ways of panels. So first, let's go with triangle panels. Cool. And if I hold my mouse on this, you'll see that it wants a surface from us. So I'm going to type surface here because I want to reference this surface into Grasshopper. And from here, I'm going to take this one. And like we did with the curves, we're going to right click, set one surface, and take this guy right here. Let me turn this off. And I have this surface already referenced into Grasshopper. Now I can hide this surface in Rhino because I already have it here. And this, if it's transparent red, it's coming from Grasshopper. And if I click on this, it will be green. So this is cool. It's already referenced. This goes into the surface right here. And then it wants the divisions from us. So if I hover my mouse on this, we can see that it wants another integer from us. And we're going to be using, you guessed it, a number slider. I'm going to double click on this. And I'm going to say, let's say 30. And let's go 0 to 30 to 50. And I'm going to duplicate this because we're going to also have it in the V. And this is cool. And you can see how parametrically and easily we're doing this, right? 4 components, and we're already doing something really cool. So, and this is amazing because if I hit show here, and if I come back to the surface here, and if I hit F10 and I start changing it, you can see the divisions update, and we don't have to remodel any of this again. We don't even need to duplicate this and make changes to it and come back to the original surface in case we lose anything. So this is nice, but this is already a lot of info, right? It's showing us the surface, it's showing us the panels. So in case you don't want to see the surface anymore, what you can do is select the components that you don't want to see anymore, then right click and then preview off, right? And then there's also disable, but that basically turns it off completely. You might want to have it enabled, but the preview turned off, right? So that's the thing. It could also work with Control Q. So if you do Control Q, it's the preview on and off, right? And then Control E is enable and disable on and off. Cool. These are our panels. Let's see what they are. So our panels are untrimmed surfaces. If you hover your mouse on it, you'll see we have 992 untrimmed surfaces. So if you want to see it better, of course, you can add a panel. Just check it out like this. I always keep a panel around because I need it most of the time. So just to check if it's a flat list or if it's a grafted list or things like that, right? Just keeping an eye on things so that we don't get lost. All right, cool. Now, what we want to do with these is scale them. So the thing is, I also want to, let's say, once I scale them, we have this, let's say, and then we scaled it down. I want to be able to connect the outer curve to the inner curve, and then we can get some frames here, right? So we can get this part filled. So I want this middle part to be a hole. So to be able to do that, we're gonna have to get rid of the surface. We don't want this to be a surface. So we want to turn this into curves first. Anyways, curves work way lighter than surfaces in Grasshopper and in Rhino in general. So it's better to keep our definition light by doing that as well. So to take the curves here, what we'll be doing is double click on this and we'll say edges. And brep edges will give us basically the edges of that brep, which could be a surface or it could be a solid or any NURB that or mesh actually. Actually, it's NURBS. If in case of a mesh, it would just be a mesh. It wouldn't be a brep. So just think breps are usually solid, but they can also be surfaces. Cool. If I enter this these panels, these surfaces into the brep here, it's going to give us a few outputs. And basically, let's check where our lines are. So these are just lines, right? So looks like here they are. We don't have any others. So these are different types of edges that we get, but just because we have only naked edges, and naked edges are basically the edges on the side where there are no edges anymore. So in case of a box, let's say, this would have been an interior curve. It wouldn't have been naked. But all others, let's say this is not a box, this is like a polysurface, right? It's two surfaces that are joined together. Because in case of a box, all of them would have been interior edges actually. So in case of a polysurface like this, these would have been naked, and then this red highlight would have been interior. So manifold would have been basically you have two edges on top of one another, which is a different case. So in this case, we only have naked edges, and these are it. And we're getting a list of lists. So we have lots of lists here. We have 992 lists, which is the same number as our triangles. And each list has what? It has 3 line-like curves, which is a fancy way of saying lines. So we have 3 lines in each. And the reason for that is because we're getting 3 lines from each triangle. And basically we're getting each triangle, each 3 lines that belong to one triangle in a sublist, right? So this is really good because in case it was a flat list, and another cool way of flattening or grafting a list is just right-clicking on that input or output, and then basically telling Grasshopper to flatten or graft that list. So if I flatten this, we're going to get all of these lines in one go. But we don't want to do that now. Please don't do it. Actually, you can just go ahead and remove it. And then you can also graft it, but we don't need to graft this further because it's already a grafted list. And now we have like a higher structure, but we don't want to do that either. We already have it where we want it, and this is good, right? Another way of checking this out is through the param viewer. So param viewer is something really cool. So the way it's done is that it shows you have data with 992 branches, which are the sublists. So these are each one is a branch. And then it shows you how many items you have in each of those branches. And if I double click on this, you'll see a visual presentation of this whole thing. And so let's say here, if I type 5 here and then 6, 5 here and then 6 here, what we can see here is that it's giving us 36 basically branches, and then each one has those 3. They're very close here, so we don't see them. 3 items inside as well. So this is a visual presentation. So this is cool. And now what we want to do is hide things. And then what we want to work on is scaling these guys here. So I'm just going to get a scale. And what scale wants from us is the geometry we want to scale, and then the centroid, or the center of the scale, which by default is the center of the world here. So if that's not what you want, and that's not what we want, so we want to scale each triangle with its own center, right? So to get that, the easy way is to get an area component, which in addition to the area, it also gives you the centroid. So if you get this guy here, you will get the area of those triangles, and then you will get the centroid of each triangle, and then you can use that for the scale, and you'll get something like this. And the reason this works is because we have the same amount of curves here as we have centroids, because we basically have 35 polylines, and then each one is giving us its centroid. Together they get list matched, and let's say the triangle at index number 0 gets scaled by the point at 0, which is its own center, then 1 with 1, 2 with 2, etc. So list matching works in the background for us, and it does magic. All right, pretty cool. The thing is, this might not work with hexagons, for example, or diamond panels, right? The reason for that is because area works with planar elements, and triangles are always planar, so they work. But let's say if I take this surface and put it into the diamonds here, and I'm going to have to turn these guys off. So we have these diamonds, diamond shaped, and UV goes here. Same UV controls 2 of them. So we have something like this. It's pretty good looking. And we do the same thing for it. We basically turn it into curves this way. But then you'll see that this is not working because these guys are not planar, right? So they're not like rectangles in one plane. So for that, we're going to do something else here. What we will do is, let's say we have this curve, and this is just a polyline drawn in Rhino, and we get this continuity. What this continuity does is that it takes, or it actually gives us, the points where this polyline breaks, or this curve breaks, and it doesn't become continuous anymore. So if I reference a new curve here, and then set one curve and take this curve in, and get this guy right here, you'll see that we have all the points given to us as one list, and that's the points where this shape gets discontinued. And this works also in 3D, of course, even if this is not planar, right? And if we get the average of these points, we will have the centroid of this whole shape, right? So this is really cool. And so instead of this newly referenced curve, if I input these diamonds that we have to the discontinuity, we get, basically, discontinuity gives us 4 points from each polyline. And then average will give us 1 average out of every list, because we have each of those 4 points in one list. So we get 1 average centroid point from each of those 4. And then we can just flatten this so we can have it in one place, because there's no point of having list of lists that has just one element inside, unless you're dealing with more advanced topics. So here we have all the centroids now. We can just deal with this and we can just scale it and voila. All right, this is really great. And the best part about this is that it also works with the triangles the same way. All we have to do is just place this here and then we have triangles instead of the diamond shapes. Awesome, right? And in case of hexagons, the only difference is that we can't just do this because the hexagons are already curves. So we're going to miss a step. Instead of turning them into curves first like this, we're just going to directly input them right afterwards. So whatever happens after this is what needs to happen right after here. So we can just do this, for example. We can cells go to this guy, the geometry, then cells go to the discontinuity, and then that's it. All we had to do is that. But there's an easier way of doing this. So instead of just manually doing one by one, we can take everything that's going here and input it here. And the way I did that is I held Control Shift, and then I dragged everything that's going into this output to go into this output, and I just let go. And this is really a cool way of changing things in your definition. So far, so cool. I'm going to take the diamonds here, and then this goes here, and we're gonna stay with diamonds for a second. But of course, for your own example, you can deal with any of the three or even any of these guys right here. Just feel free to experiment and have fun. All right. Awesome. So we scaled them down now, and let's try scaling them differently. So for the factor, we can use a number that's going from 0 to 1. But the thing is, if I do that, I'll see that I have just 0 or 1 here. So for that, I'm going to 0 to 1, but then I'm going to do 0.00. So it gives me some decimals, and it's not an integer. As we can see here, it takes a number as it shows 0.1 and not necessarily an integer. So if I input this here and I give it some number, so 1 means no scaling happens. Anything between 0 and 1 is just making the scale smaller. Of course, we could have used like number 2, but that would make the whole thing a mess because it scales it further, and we want to use these as frames, so we're going to scale between 0 and 1. And that's cool. That's really, really cool. All right, awesome. That's really awesome. And what we want to do next is we want to loft these guys together so we can have those frames. So the thing is, if I take loft here, and please don't do this with me, you'll probably crash it. And let me save this whole thing so I can send it to you later. Let's do surface paneling plus scale, framing. All right. So loft, if I take all of these guys and loft them together, you'll see we'll have a crazy thing, right? So the reason for that is because it doesn't know that it wants to loft, for example, this guy first and then with this guy second, and then let go of that and then go to the other. The reason that this happened right now is because we have a huge list of all of these polylines, and it's trying to loft all of them together, right? And that's what we're getting. This is not what we wanted. And we also want these guys to come into the play. So we want to put these two lists into one list first. We want to merge them together. So this guy first and then this guy second. And what this will give us is that you'll see here we have 133 polylines, and here we have 133 polylines, but here we have 266 polylines, which is the sum of the two. And this is now one big list made out of these scaled and non-scaled geometries. But the thing is, still, if we try to loft these guys together, it's not going to be cool because um, it will try to loft them all together. What we want is a list that these outer ones go first, and then the second goes, the inner ones go second, and then that's just one list. And then the second one is another list, right? So we want a list of lists that is made up out of 2 polylines each. So if you feel free to pause this at this moment and think about how you would do that. And if you did, and you came back and you already figured out that we need to graft these 2 lists, good job. The reason for that is because if you graft this, and then you have the other one that you graft, and then you have 2 lists made up out of 2 lists, and instead of merging them this way, you merge the grafted versions. What you'll get is basically, instead of merging big 2 lists together and ending up with one bigger list, what you'll have is 0 merging with 0, and then giving you 1 list, and then this one merging with this one, and then giving you another list. And one more thing, don't beat yourself up if this is not super clear to you as of yet. There are users that use Grasshopper for years and years before they get before these things become very intuitive to them. So if this is not super clear to you, like, definitely don't beat yourself up about it. Just do your best and go forward. The more you do, the more you learn. And hey, this is probably the first time you're using Grasshopper, so seriously, this is very cool. You're doing really great. Okay, so now that we've merged these 2, we can loft them together. And of course, the loft will happen between these 2, and then these 2, and then these 2, and we'll get exactly what we wanted. This is awesome. So we got this paneling, framing happen just like that. All right, cool. Of course, we can just change it to something else. We can just take these here and then put it into the hexagons, and we get hexagons. Or we can just put it here again and then use triangles, right? Awesome. I'm still going to go with the diamonds, but just wanted to show you the power of Grasshopper, right? Even at this stage, you can still change even the main paneling. And the best part is that you can still go back to your surface and change your surface right here, and then still the whole thing will update right away. And that's super, super awesome. All right, then all of these are now open B-reps. Basically, they are poly surfaces. And then a while back, I said B-reps are usually surfaces or solids. They can also be poly surfaces, which is a geometry made up out of different surfaces joined together. So I'm just going to flatten this whole thing so we can have it together. And then I'm going to join B-reps. So B-rep join, if I don't flatten this, it's going to try to join each one with itself, which doesn't make sense. But if I flatten it, this whole thing will try to join together. And we will have one big poly surface made up out of all of these right here. And that's awesome. That's really, really awesome. Okay, so we've made it this far. And let's do one last thing. And this is from Pufferfish. So for this tutorial, you needed Pufferfish and Bifocals. And also, you would have needed LunchBox, of course. So from Pufferfish, there's a cool component called offset surface. And offset surface, this one, not this one. Please use this one right here, the one that has a solid in it. And what this will do is it will give this thing a thickness. And that's why we joined it, so it can solve its intricacies inside. And so before I do that, I'm going to input some distance over here, which is how thick it gets, basically. Let's try 25. And of course, this would have been a number. And then here you might see both sides. And for both sides, it's telling you, give me a number here. But you probably can do this with a, so you'll get, you can do it with a Boolean toggle. So you have a Boolean toggle here. What that does, that basically true and false. So if it's true, it's probably both sides, and if it's false, it's not both sides, right? So, and then, yeah, we just need to put this surface right here. And this might be heavy, but it does the job, and it's cool, and we can change the thickness anytime. But you can see that it already made the whole thing pretty heavy, right? And so that's why usually you might want to disable this also. Although there are better ways to do this, but right now, as beginners, we're just going to disable it, and we can make the changes on the fly. And I'm just going to make this cleaner by putting these here, but I'm going to graft these guys together. But I know I'm going to be doing a very, you see, if I graft this and keep this flattened, it's gonna cross-reference and it's gonna go crazy. So if you know you're gonna be doing something crazy and you're probably gonna crash it, first of all, of course, you wanna save it. And the second of all, you might wanna disable your solver. So once you do that, nothing goes on, and you can graft and flatten as you wish. And then once you're done making your changes, you can enable solver again and then go with that. So that's something you might want to keep in mind as well. So right now, I can make the changes on the fly. So I can change these numbers, for example, right? Like the divisions and everything and whatever I want to do. Once those are done, once I'm done making those things, I can come back and turn this on, or enable it at least. So that's done right there. And now we want to bake this. So because all of this at this point is just Grasshopper geometry, right? Until this point, we've just been doing everything in Grasshopper. None of this is in Rhino yet. So to make it in Rhino, you have to bake it. And cool saying we have at Futurely is bake it till you make it. You know where that one comes from. So right click, and then you have to hit this egg icon here with the bake, and then you can decide to group them or not. We only have one brep anyway, so there's no need to group them. You can decide the layer you want to drop them in, and that's it. Okay, that. Now we have this in actually separate polysurfaces. Oh, it's a lot of polysurfaces. Just a second. Okay, we did need to bake this with a group then. Yes, let's group them. Now it at least comes as a group, and this is really cool. So now this is in Rhino, and it's a group. We can always ungroup it and just see the parts, or we can just keep it as a group. And then if we do rendered, we can see it this way. And that's awesome. All right, maybe Arctic. All right. Rendered was better. And let's see. Of course, I can just move this to the side, and what is this one? Create solid. You can see when you see this black and white yin yang looking icon, it means it's a Boolean toggle. So you might want to have another one of this in case you didn't want this to be a solid. But until this point, I'm cool. And we can, for example, push this to the side, and maybe we can make some differences here. Let's say I'm going to disable this. I'm going to make the changes here. Maybe I can turn this one on. And all right, all right, I like this too. So I'm going to also enable this one in the end, and then I'm going to bake it again. Right? So you can bake as many variations as you want, and that's the best thing about, not the best thing, but one of the best things about Grasshopper. Cool. So let's do one hexagonal thing, and that will be it for today's session. So that's the hexagon. That's cool. Let's bake this one in. Actually, let's make some changes. Maybe turn this into 30. You can see it takes a long time because this is turned on. We have to disable it again. Okay. This is too much. Let's make it like... All right, I like this. Now we can turn this on again and then just bake it. All right, I guess that is it for today's session, guys. I hope you learned a lot. And if you have any questions, just ask in the comment section down below. And keep practicing. If you produce any results with this introductory session, please send it to us. Post it on Instagram, on Facebook, stories, tag us so we can see it. We would love to see what you do with the knowledge you gain from these tutorials. And as always, thank you for learning. Have a great day. Goodbye.